So welcome back. So this is what I want you to do. I want you to take out your notes and I want you to give it a try, just graphing this function. I know a lot of you don't have grid paper, but let's just see if you can eyeball it. So you have around 3 minutes to do this, so let me know. There we go. So now let's see. So for this one, since this is like a half, negative 1/2 times x minus a half, as I was looking at this problem, I didn't want to kind of like do my y-intercept and then do my slope because this is a negative 1/2. It is really difficult for you to just graph a half and then go up a half. So the first thing I was thinking as I was doing this, it's like, can I combine the two? So that's exactly what I did. So I combined them in the form of negative x minus 1 divided by 2. So now, if I'm looking at this, right, I'm thinking that if I'm making a table of value, I want to pick odd numbers. So 1, 3, 5, 7, 9, and then also the negative version of those. Because if I pick an odd number and then I subtract 1 from it, it's going to give me an even number, and then the even number is divisible by 2. So now remember, the bare minimum that we need is 2 points, right? So we can trace my line, so I just want to spread them out. So the first point I picked, it was negative 5. When x is equal to negative 5, we have that negative 5 times negative 1 is going to be positive 5. Positive 5 minus 1 is going to be 4. 4 divided by 2 will be 2. And then the second point, I think it was negative 1. Was it negative 1? Yep, it was negative 1. So negative 1 times negative 1 will be positive 1. 1 minus 1 will be 0. 0 divided by 2 will be 0. So that gave me my 2 points. Other points that you could have picked, you could have picked negative 3, negative 3, 1. You could have picked 1, negative 1. And so on and so forth. But then again, I only needed 2 points, so that's what I did. Less is more in this case. So then, this is what I want you to do. I want you to take a minute, pause the video, and I want you to write this down. So now this is your definition of a quadratic function, which you can write in the form a times x squared plus bx plus c, such that x is not equal to 0. So now, I just want you to think for a minute. If a is equal to 0, that means that your function, instead of being a quadratic, it will become bx plus c, which then will become a linear function. So just be careful about that. Just remember to keep that in mind, okay? And then the graph of a quadratic function, they all look into kind of like a U, and that's called a parabola. And then we know that the parabola has symmetry, and that symmetry, it goes about to the axis of symmetry, which intersects the parabola at one point, which is called the vertex, which you guys saw on your last video. And then the vertex is the point where the graph changes direction, which again, it goes from either positive to negative or negative to positive. So there you go. So now, let's see if we can graph f of x equals x squared, okay? There we go. So the first thing I want to do, I want to find my axis of symmetry. So remember, the axis of symmetry is equal to x equals negative b divided by 2a, right? So now, look at this, because my v value, Starting there, actually I can write this as x squared plus 0x plus 0. There we go. So now my b value is going to be 0 minus 0 divided by 2 times 1. Okay? My axis of symmetry is going to be x equals 0. X equals 0. And then I'm just going to put that in here. So now, this line right here will be my axis of symmetry. There we go. So now, my vertex, right, it happens at my axis of symmetry. So I'm going to take g of x equals to x squared. And now, I'm going to substitute that x value into my function. So now I have that this will be 0 squared, which 0 to the second power is just going to be 0. So now I have that my vertex is going to be 0, 0. So it'll be this point up here. So now notice, my leading coefficient is positive 1. Since 1 is greater than 0, I know that my graph is going to open up, okay? So now, let's see whether that's true or false. So let's see. So now, I want to pick some values, okay? So I'm going to do x. And I'm going to do x squared, okay. So now, one thing that you want to remember, your axis of symmetry, you always want to put it in the middle of your table. So let's see, I'm just going to do a couple points. So I'm going to do, let's see, -2, -1, and then, let's see, I'm going to do 0, 0. Oops, let me change that all this point. That was that point there. And then I'm going to do -1, and then I'm going to be -2. So now you have -2 squared. It's going to be 4. So your point is -2, 4. -2, 1, 2, 3, 4. There we go. And then your second point, -1. -1 to the second power, which is -1 times -1 is positive 1. So that's -1, 1. And now we'll do the same thing for the next one. So you have -1. Oh, I'm sorry, that should be positive. Because then I'll be doing the same points. There we go. So now, this will be positive. There we go. So you have 1 squared equals 1. So then again, I'm going to graph that point, 1, 1. And then your second point, you have 2 squared, which is equal to 4. And then 2, 1, 2, 3, 4. There we go. So now I have my points, I just got to connect them. So let's see. There we go. And so it matches what I have. So notice it's a happy face. So my graph goes up. I got my axis of symmetry. I got my vertex in there, and then I have my points. So one thing that's key about the axis of symmetry is that if I was to fold this paper in half, my points will lie on top of each other. Because if I was to take a ruler and And I should measure the distance from this point to that point. Let's say this will be 1. Will be the same distance from this end to that end, and then from this point to that line, and this point to that line. So that's something cool that you can do with your axis of symmetry. Then again, this distance will be the same as this distance, and then this distance will be the same as this distance. So actually, after you find your vertex, you don't have to actually do the whole graph. You can just do one side, and then you can just kind of like, you can reflect it over your other side, and then you'll be good. So you don't have to do all this work. So now, this is what I want you to do. I know, I understand that we are a little limited on graphing paper and all that, so on the resources we are a little limited, but I just want you to kind of like give this a try. So if you give f of x equals -1/2 times x squared, right? So now notice, leading coefficient is negative, so this is going to up and down, right? Going to up and downwards. Your point, you're going to have a maximum. And then if you look at this one, you know that this one's going to open upwards, right? And then that leaves you with your vertex is going to be a minimum. There we go. And then you just have to find out what is your axis of symmetry and what is your, you're going to have to kind of like do some points and then kind of like just plug them in, and then you get a nice beautiful graph. On your graph, you have to make sure that you curve your graph, because if you don't curve it and you get some kind of V, that's an absolute value, which is a completely different function, so you just have to be careful with the graph, okay? And then the last thing I want you to do, I just want you to think about these two questions. So in your own words, I want to describe how does knowing that axis of symmetry helps you graph a quadratic function. And then the second one, what does the vertex of a quadratic function represent? Then again, I just want you to think about those questions because those are key into graphing a quadratic function. There we go. And that'll be all for today. Then again, I'll be posting the homework. And then let me know if you have any questions, any problems, just email me, send me a picture, whatever you got. All right, and then we'll do it again next time.
It's payday.